if I may, then I'd like to go on to the next topic, and I'd like to bring on Chet Haase to talk about, well, anything really, whatever you think is interesting.
Oh, I like that agenda. It suits my frame of
It's like
mind where
anything, right?
I have nothing in particular to talk about. So let's just talk about anything that comes up.
Okay.
Hey,
Okay, so well, I did kind of prepare a couple of things which I thought would form the
yep.
basis of a dialogue. Dialogue, multi-log. Can you have a multi-log? I don't see why not. So, well, first of all, can you see my screen? Yes, hopefully you can. So Chet wrote this really fantastically good book, I think, called Androids, the team that built the Android operating system. So I read this through, and I found that extremely useful because as a practitioner of hacking around in the Android operating system, it was really useful to see the design decisions and the processes which gave rise to certain things that we love or not love ever since. So I asked Chet along basically to kind of expand on that a little bit, and just to kind of review how Android came to be, and also the, like I say, the implications, the things that we have to deal with every day. One of them being the build system, but maybe we'll pass over that. But yeah,
One of my
so I'm
favorite
wondering if we could
things
just
about
start off
Android,
with.
obviously.
I have some theories, but we'll probably not get there.
Okay.
So yeah, I wonder if we could just start off then with kind of an intro to kind of how you got involved in Android. And
Sure.
well, my very first question is, why did Android succeed when so many other mobile operating systems from the late 2000s failed horribly? So what was it that Android did? Well, the Android team did
yeah, many
that
things.
worked
So
out.
it might help to have, so thanks for mentioning the book. Just, it might help to set a little bit of context just so that people know where I'm coming from. Because most textbooks are written by journalists for various reasons. I don't think these stories are really written from the inside. One is people would rather write code than text, and they don't really have time for it. And also, I think companies are very risk averse, PR departments and legal departments in particular. So this is an interesting book because I was on the inside when I wrote it. I am no longer on the inside. I was not part of that original team. Additional context that helps. I'm writing about how Android came to be from its beginnings up to about 2009, which is where things started to pick up with the Droid, the release of the initial Droid device. And that's where the story ends. I joined in 2010, about a year after that, and sort of got to see the eventual success that came from all those early bits. But I really wanted to, the reason I was writing the story and researching and having all these fascinating conversations with the people that were on that early team was I thought it was an interesting story about how it worked. In particular, to your question, how in a market that included Microsoft and RIM and Nokia and then Apple coming out of nowhere, how Google then came out of nowhere to be one of the two, right? Within a couple of years. And it was really sort of, it wasn't just that it kind of worked and it eventually became successful. It was like, I joined in 2010 and it was at the bottom of the heap, right? It was clear that Android was real and people were buying devices and OEMs were coming online, but there were probably 5 players in the market and we were 5th. There was obviously Apple, although they weren't quite there yet. Like they were on a really good trajectory. They were the interesting device that everybody was keeping an eye on. But there was Microsoft, and frankly, what did a colleague said? Oh God, I hate these gestures on the Mac. I wish that wouldn't happen. A colleague once said years ago, if Microsoft gets into your market, get out, because I think they are known through most of my career as a company that will get things right eventually if they care, right? They are really good at shipping software. They may not be good, maybe that first version of the thing is not the thing that you need, but they have deep pockets and they have smart people and they have drive to do things, and they'll just keep chipping away at it until they're there. And so they were going to be in this market, or they were in this market. So that's obviously a concern. And they were doing okay with some of their early Windows Mobile, a couple of different flavors of platforms that they were licensing to people, not doing their own phones for various reasons, some of which I mentioned in the book. There was RIM, which had its incredibly loyal, religious fan base, these mostly sort of business folks that thought that it looked cool to have something hanging off your belt. And the keyboard, everybody loved the keyboard. How could you not have that keyboard associated with it? That's obviously the thing that you need on a smartphone. And they had really good secure email and messaging, syncing, like all of that stuff was really important for smartphones of that era. So obviously they're going to continue to be a factor, especially in the enterprise space. And then you had Nokia that basically owned every phone on the planet that wasn't those, right? It was like 70% market share, mostly feature phones, but they were also starting to do some smartphone stuff in that very early era, 2005 to 10, when this stuff was coming online. So all of these players, like deep pockets, been there for a while, huge competition. Apple, comes out of nowhere with obviously a really compelling offering, and then why Google? Why Android in particular? I saw some people discussing online, Google bought this Android company and then they shipped their phone. I'm like, no, what Google bought was a team that had 8 people, 3 of whom were writing code, and they didn't even buy the code. The code was basically a JavaScript demo. It was 3,000 lines of JavaScript to show people a vision of what it could be. And I've seen screenshots of that thing, and like, that's not the thing that it was, but what it was a vision of like this integration of the basic capabilities of the phone, and then you also have easy syncing with your your messaging and your email, like the ideas of what a phone should offer and did offer, although it offered it in eventually a very different way. But they got to Android. These 3 developers is basically Brian Sweatlands, Andy McFadden, and Ficus were the engineers on the team at the time, and then they had some other people doing more businessy stuff. The founders, there's basically the 4 co-founders, and then Tracy, who is still there. She was an admin assistant for the entire team. And that was it. And so they basically push reset. They started working on this thing and then built it all from scratch. So the question, I'm sorry, I'm sort of veering all over the place here, but it's a big story. The question is, why did it work? And there were several things that I explored in the book. And I think that one of the main things, probably in most projects, why did it work, is the bit about timing. Like, if you're not doing that thing at the right time, it doesn't matter how good or bad it is, it ain't going to work, right? Because nobody is looking for that thing. So there was a timing window that was really crucial to this thing working. And I don't think, like, everybody could sort of see, or at least, the people in the domain, people like Diane, they could see this convergence of hardware capabilities. Like, the screens were getting small and dense enough that they would be interesting. The touchscreen capabilities had come online while they were working on this stuff, in a very real way. CPUs were getting better. GPUs would be there eventually, although they weren't there in 1.0 in a big way for mobile devices yet. Memory was getting cheaper. Like, all of the pieces were sort of coming together where you could envision a device like this. They didn't know exactly when and how it was going to hit. But they happened to be around with a platform that had the capabilities that OEMs needed, that manufacturers needed at the time when consumers wanted it, right? That was the timing element that really worked out well for them. They didn't aim for it, but they happened to be around and capable at the time when the window opened and before it closed, right? Because the other element of timing is, okay, well, there's a window. Are you going to be done, or is somebody else going to be done before you? So if Google, or if the Android team at Google had kept perfecting the thing that they were working on and not shipped at the right time, maybe we would be having a conversation about WebOS, the stuff that Palm was doing at the time. And they were taking a very different approach. They had some really interesting things that didn't quite come together soon enough, not, fast enough or whatever it was. Like they weren't quite right at the time when the market needed it. And eventually the market moves on. And then the other question, of course, is why did these other companies not succeed? And I think everybody had their own reasons for not succeeding. But on the Android side, it was, let's start with timing and say, well, they were there when they needed to be there. But there were other elements that really made it work as well. One of them is obviously like the team. There was a bunch of people, the right people were there, by which I mean they hit the ground running. The people that Android hired at that time, for the most part, were domain experts in platform development. And there's not a lot of those people. Like the people that some of those people were at B, writing an operating system that I think of as cult classic. Like if you're a consumer outside tech, you have no idea what I'm talking about right now, right? But the people who are into operating systems know B. It was a really interesting multi-threaded operating system, multi-threaded UI and graphic stuff, really good for media stuff. And they continued to not succeed for about a decade until they finally fell apart. Palm acquired the IP of B, and those people then got spun out into Palm Source. And this meant that people who came to California or the Valley to work on operating systems for the sake of working on operating systems were now part of the Android team and got to apply that expertise and that passion into this new operating system possibility. You also had people from Web TV or the Web TV division of Microsoft, because they acquired Web TV early on in like 97. And then you had people from Danger in Andy Rubin's original startup that did an earlier version of smartphones when the hardware was even more incapable of handling it. But they were able to sort of do that earlier thing. So obviously they're coming in with the right expertise. So they worked really hard. They had the right experience, and they could sort of run fast enough to do what they needed to. There's an interesting business aspect why it worked, which is a combination of things. One is open source. I think in particular for your group here, Chris, open source, I think, was really key as a decision to make this work, because some of the people that had worked on earlier versions of this kind of thing, like Diane at Palm Source, observed that when company A does a platform and wants company B to license it, company B is very wary of doing that because they don't know what's going to happen next year to company A. Are they still going to be in business? Are they going to change the licensing terms? Are there going to be things that basically tie the hands of company B? And now they bet the farm on something that they don't control. Right. So Palm Source had done this platform and they were talking to OEMs, but essentially the OEMs didn't end up wanting it because they did not control it. Right. And if you're a company like Microsoft, maybe there's a bit more trust there because Microsoft has done the licensing model for a while. But if you're a new company, why would I bet my company on your new company's thing when I don't really know the future of that? But if you release it as open source, I don't have to care. Right? Because if your company goes away or changes licensing terms or decides to start licensing it, I still have your old code. And, depending on what the license is, if the license is flexible enough, then I still have the rights to ship my platform using your code. And so just the fact that they decided to do this as open source meant that any OEM that wanted to consider it, they had already removed that barrier to entry for these companies, because then they didn't have to buy into the business plan of your company anymore. They could just buy into whether this code was correct for them. And you couple that with the time. Yeah. So go ahead.
So I can say that also had the effect of locking Microsoft out because they didn't have a compelling product at that point. And they couldn't license it because because Google were already licensing it essentially for nothing. So they couldn't. Yeah,
free is a really good price. Yeah. And I mean, if the offering is compelling enough, like people may pay that licensing thing. Like, I don't know what the per device cost was. Obviously, manufacturers want to keep that cost at a minimum, but if the free thing has enough of what you need and you can invest more engineering to, tune it to your specifics of your devices, that helps. I think the Microsoft thing, like, I can't speak to the internals of this, but I know people had the experience of it being difficult to port because it was a black box. Because the other element of AOSP or open source in general is not just that they got the code and could ship this thing for free, but also they knew how it worked because they could look at the code. So when they wanted to port that thing to their particular drivers, their hardware, the features that they wanted, they could figure it out, right? Engineers can look at the code and understand what they need to do, as opposed to a licensed operating system where that company doesn't want to share the code because that is their IP. And that just makes the porting situation that much harder. If your porting layer is not automatic, which it tends to not be, then how do you get there? And it was this careful dance between, the developers on one side and the developers on the other, just trying to like marry their code somehow without either side being able to look at the other one. And it was very painful. So not only the cost of the licensed operating system itself, there's that lovely gesture again, but also just the hassle of porting something that you really didn't quite understand and never would because you didn't have the access that you needed to it. And then the other element I wanted to mention with AOSP is, and this ties into the timing thing, was counterintuitively, the iPhone was really helpful to Android being successful in the following way. When the iPhone came out, they kind of defined in the minds of consumers and manufacturers what a smartphone now needed to be, right? So they came out with a device that said, we didn't invent touchscreens, but here's how we think it should work in smartphones. And a bunch of consumers and manufacturers said, yep, that's the way that is now defined what a smartphone is. And none of the manufacturers really had a compelling touchscreen story at that time, nor did they have the capabilities such that they could launch that anytime soon. And Android was their first device at that time was not a touchscreen device, but they did have some touchscreen capabilities built in. They were building toward that future. So basically the iPhone coming out made all of the manufacturers and the carriers take a step back and think, okay, I should point out too, when the iPhone came out, the people who benefited from the iPhone were Apple. Yeah, right. So if you weren't Apple, if you were not the manufacturer of that device, you did not get to benefit from that community. And on the carrier side, they picked a single carrier in each market because they really needed that carrier to invest in things. So they had a lock-in for AT&T in the US and similar things across the world. So if you are any company that was not Apple or one of the, the chip manufacturers they worked with, you had no solution in this new market that they were essentially creating. And so you really wanted a competitive device, and you looked at the operating system and its capabilities that you had internally, and you realized that was not it. And then they go shopping and they think, okay, what else can we do here? And Android was close enough to the end, and it was open source. So all the things I mentioned before. And that timing thing meant, okay, now the OEMs were interested.
Absolutely.
There you go. That was a really long answer.
Well, it covered all the bases. Yeah. I mean, the thing that interests me most about Android is the fact it is open source, and therefore I can do things with it, and I can port it onto all kinds of weird equipment. And I have done that over the years. And as we've seen, it's now appearing in vehicles and cars all over the place. So it's kind of the malleability of the whole thing makes it interesting from a developer's point of view. And also it means it pops up in all kinds of strange equipment.
It certainly does. Yeah.
One odd use case I've discovered is navigation systems for yachts. Chances are, if you have a big yacht, they almost all run Android on the navigation system. But it's a deeply embedded version of Android. It's running a lockdown version, which just runs the navigation app. So you're probably not even aware it's running Android, but that's what it is. So we've seen it. But there are millions or billions of devices out there running Android, which are not smartphones. Yeah,
I think that, I mean, there's probably various reasons for that, but I think certainly a strong one is it was a complete system. So there were companies or communities and open source communities trying to do smartphone things based on a Linux kernel at that time. I forget some of these names. You probably know these better than I do. But they were, and TI had some solution that was like, well, you use, this, but then it was like, oh, and then you do all these other steps. And then, miracle occurs and you get a smartphone. And if you're a manufacturer, it's like, okay, well, now I need to like write drivers for this and license this from them and get a chip over there for doing that. And like, that's not a smartphone platform. That's a kernel and a bunch of phones. And what Android did in particular was, there was a Linux kernel, and then there was all this other stuff that they gave you with AOSP. So you still might need to write a driver for your device, but you know what? If you have a driver that talks to Linux already, you're not really that far away. And they gave you some reference drivers for some typical hardware at that time, and then more and more came online. So the market for all of these devices, like, it's kind of crazy that now I get a plane and I'm, watching Android in a TV, or there's a refrigerator running it, or yachts, or, all of these random things. But it's because people, they don't want to worry about that part of the equation. They have a piece of hardware that they're trying to sell. And if they look at what they need to do to like start from a kernel and then build their own operating system platform, like, well, that's too much work. Is there anything that just gives me everything I need? And the answer, it happens to be Android in a lot of cases.
Yeah, exactly. And I get to talk to a lot of people doing that kind of thing. And hey, that keeps me busy. So it's given me a job. So I'm happy about that.
Nice.
So moving on then a little bit, I'd like to talk about a couple of specific details, which I think you would be familiar with, particularly the graphics infrastructure for Android. So going back to late 2000s, 2008, 6, 7, whatever, Android shipped with OpenGL drivers. And at that point, not many people knew what OpenGL was. So that was quite a brave choice to do at that point. What's the rationale behind that, do you think?
So Android at that time, like one of the things that allowed the team to run really fast was they had individuals that owned large swaths of features in the platform, which meant like they were they were not just the owner, they were the person writing all the code as well. And they probably had 2 or 3 of these things. And on the graphics side, that owner was Matthias Agopian. And he had a lot of graphics knowledge coming from years working on B and Palm OS and stuff before that as well. He knew a lot about GL and using OpenGL to do hardware accelerated graphics stuff. And he could see enough of the future of like, these things are coming online, like GPUs are becoming more prevalent. OpenGL is really the only mechanism to talk to that hardware. I mean, Microsoft had DirectX, obviously, but that is Microsoft's. And OpenGL was the way to do that in the broader world outside of that platform. And this was going to be required. Like, if you want your devices to be faster at doing graphics, and as displays get bigger, you're going to end up doing hardware accelerated graphics. So he made the decision internally, like, what they really needed to do was just display pixels on the screen. But he thought, okay, well, I could, write my own code to do that and talk directly to the drivers, or I could write an intermediate layer that talks OpenGL, and then I could write a software processor for OpenGL, and then I can start Android just speaking OpenGL. And for the first part, it's just going to speak through this sort of software layer, basically an emulator of OpenGL. But then when GPUs come online, we can just flip it over and start talking to a GPU instead. And that is, in fact, what happened. So it was a really good guess, but I think it was a very informed guess, because he'd been doing, similar stuff. Like, he knew enough about the domain to sort of connect the dots. The interesting part for the timing of that, though, was Android was really good at that time about being very pragmatic of, like I said, timing was crucial, right? We need to do this thing as fast as possible. They started, that reboot was, July of 2005, and they had 3 developers. By the end of the year, they probably had 15. When they shipped 1.0 3 years later, a little over 3 years later, they had maybe 100 people total. So not a lot of people, we need to do things really fast. So they didn't have a lot of parallel projects in multiple ways, and they weren't doing a lot of like rewrites internally. It was like, okay, solve this problem, on to the next one. But occasionally they would step back and say, what's the better solution for the long run? So some of these decisions were made on the framework side in terms of, communicating between different processes. And that decision on the graphic side was made by Matthias, where he realized, okay, we're going to need something better. Like the fastest thing for me to do would just be to write my own software processor. But the better solution in the long run would be to actually layer on top of OpenGL, because that's going to get us to a more scalable solution eventually. And I don't want to paint us in the corner before we get there.
Yeah, and it's a delicate balance between taking the approach that will give you the quickest solution and taking the approach that will give you support in the long term. So yeah. I guess particularly when you're in kind of startup mode, do you just go straight for the door, or do you kind of find a solution that's going to keep you going for a little bit longer? And that was a good choice.
Yeah, it's fortunate.
Okay,
and now it's what, 16 years later, and there are things are moving. OpenGL got better, bit by bit. EGLSE. I'm sorry, I'm missing all the acronyms here. They went through version 2, and then version 3 is current, but I think maybe some manufacturers are still on 2, but then we have Vulkan coming up, right? So things change over time. But what he did originally sort of gave a really long runway to get running on all the devices that they needed in the first few years.
Sure. Yeah. Okay. Cool. Another little topic, the choice of app programming language. So we have Java and Dalvik, but that wasn't the original choice. Could you talk about that a little bit?
Sure. So as I said, the demo was originally JavaScript, and I think there was an assumption that that would be one of the languages that they used for a couple of reasons. One was the demo was in JavaScript, and obviously like the developer community for JavaScript was pretty huge, and maybe they want to play off of that. So I should point out initially that because they were a new platform, if they could make the barrier to entry as low as possible, it's going to help them, right? They wanted developers writing applications for this thing. So they want to make it as easy as possible. So JavaScript was obviously a consideration for those reasons. And also some of the early stuff coming in. So Android at the end, the Android team at the end of 2005 acquired Skia, the company that basically brought in the low-level graphics rendering stuff. And they had some stuff, like they had a UI toolkit that was doing stuff through JavaScript. And so there was like other reasons for them to consider this. So there was an assumption that they would use that. A lot of the people coming onto the team, as I said, were domain experts specifically in doing platforms, operating systems, and low-level embedded stuff. And their assumption was we need C++ because we really need to be as close to the metal as possible. We need control over all of the memory allocations and everything we're doing. We don't want some runtime making some mystery performance choices between us and the metal. And so C++ is obviously going to be the right choice for an embedded system. And then there's this Java programming language as well. And Java was popular with many developers around the world for various reasons, but it meant that there was a nice, there was the same low barrier to entry because developers knew it. And there was also a pretty good ecosystem of middleware and patterns and practices. And so that should be a consideration in the mix as well. And so they sort of went forward from that July timeframe thinking, okay, well, we're going to have 3 languages. And that continued for a few months as they're building sort of, the infrastructure below them just so they have something to build on. And then they got to the end of that first year in 2005. And there was conversations between people like, Brian Swetlin and Andrew Rubin, that, they had like 10, 15 people on the team at that time. Why are they trying to target multiple languages? Like this was one of those pragmatic Android decisions of realizing, okay, that's a good idea, but here are the realities. Like we need to focus. and put everything behind one direction in particular. And so the choice is made to go with the Java programming language for some of the things that I've mentioned. Like, I guess it could have been any of them, but they really like the idea of developers writing these applications, these fictional developers in a future world being able to write applications with a language that they were already familiar with.
And it was in the mobile, the wider mobile industry, there was a thing called J2ME, Java
Yes.
to Mobile Edition, which was very popular. Nokia had it and everybody else had it. So I guess Java on mobile devices, on phones, was a kind of familiar concept.
Yeah, true.
But the Google team, or the Android team, didn't go with J2ME, which would be the obvious thing to do. They did their own thing.
Yes, and there were a couple of different things going on there. One was they were told that they were going to, like, I assume some of the manufacturers or partners or something. Maybe it was carriers. I can't remember who the business dynamic, but J2ME was an assumption, and that was one of the reasons why they were going with the Java programming language. Was it would allow them to have some variant of J2ME running on top of this thing. But they didn't go with like J2ME in particular, because J2ME, the original premise behind Java itself was write once, run anywhere. And then they got into the mobile and the embedded space with J2ME, and that didn't really pan out there because, various reasons, business interests and competition, but also the capabilities of these devices. So they had these profiles that would come out, and you would have this set of APIs for this class of device and this other set of APIs. And some devices, like, they would even have different profiles of J2ME across different models of the same device from manufacturers. And so it was a really fractured ecosystem. And so for a platform that was trying to be really one platform for every developer of an Android smartphone, that was going to be a tough sell. And so they just went with the language itself, but figured, well, and then we can make, J2ME of various flavors run on top of this. But by the time they launched, like, that was the assumption while they were developing, going up to 1.0. By the time they launched, nobody was talking about J2ME anymore. It just was not a competitive advantage in that smartphone space anymore. It was still around on probably feature phones, but it was not something that anyone was pushing them to do anymore. You might as well have the broader capabilities of the language itself plus the richer APIs that Android was offering on top of it.
Okay, cool, makes sense. Okay, there is a question in the chat. I'll just relate to you. So Benny says, I have a question regarding Window Manager. Every time I come across an issue or feature where Window Manager knowledge is needed, I wonder how many devs at Google have knowledge of that part of the code, and how many OEMs doing changes, and how many OEMs doing changes there by themselves. Does that make sense? So
yes, it does.
Yeah, Window. This is not a thing I know particularly much about myself. So, but I'll let you run. I'll let you run free on this.
So the OEMs, I do not know the answer to that. Like, I think there are some areas of the platform where I assume the OEMs just take what the platform team, the framework team, has done, and they're making changes somewhere else. Like, they want to change the system UI to make it, to customize it for their particular look and feel on their device. Window Manager, I would assume that most of that kind of works the way they need it to, and they probably shouldn't be doing a lot of changes there, but I can't speak to that since I have not looked at what OEMs are doing. The answer to how many people worked on it depends on what time frame we're talking about. So running up to 1.0, the Window Manager was one of many things that Diane did on her own, which is more impressive the more I think about it. So she's responsible for a lot of the framework code and a lot of the more gnarly bits of that really difficult, multi-threaded, got to lock things down and make sure that the timing is right on all that stuff. And Window Manager was at the heart of a lot of that stuff. These days, so during my time there was another person that helped out, and that became his main job, and then he moved on, and there was another person that then hired a person, and now it is a team of many people. So the thing that Diane wrote from scratch and got working for 1.0 is now an entire team of, I don't know how many people, but way more than Diane. On the other hand,
Sure.
Diane's pretty amazing. So is it better now? You know, I think the reality of any software project is if you're aiming at something in particular, like just to ship that thing, you can be very focused on, you know, just doing that. But then as the ecosystem expands and they have to have more and more capabilities, and as you need to integrate more with, you know, other groups doing these other things and all these requirements coming in, you just need more people to handle that thing and to make it more and more robust, testable, you know, automated testing, like all the things that any real software project needs in the limit. And that's why these teams expand to be more than the one person. So yeah, she was pretty amazing on that. On the other hand, I think the requirements now for a window manager that scales to, what is it now? 3.5 billion devices. You need a bit more, need a few more bodies in there to get the coverage that you need for it.
Sure. Yeah. Just to be clear, the Diane we're talking about here is Darren Hackborn.
Oh yeah, I should.
Was
yes,
one of the original or one of the early members of the team, and did so many amazing things, including, of course, the binder, which
yes,
which is one of the, it's still one of the unique features about Android. I can't quite get into my head why it is that everybody doesn't use binder. Why does it not scale beyond Android? But it is one of the things that makes Android applications kind of interoperate with each other more or less seamlessly.
And there were debates at the time, and there probably continue to be debates on whether that is the right solution for everyone for an operating system. I think Diane won that discussion. And Binder was an open source project that came out of some of the early work that some of those people had done. And then they expanded on it to make it do the right things for Android. But there were people there who preferred a sort of a lower level, more focused approach. Like Binder is a whole, you know, it's a language independent thing. You send these messages through, and I think there was it blocking at the time, and then they found a way to not make it. I can't remember, but there were like various debates about how the thing should work. But there were people on teams that are like, I just want a socket. Just give me a socket and I'm going to pass my own messages. I don't need a whole framework thing. So to some extent, it was a more complex solution than some of the people wanted. But the framework team essentially won that particular discussion, and Binder it is.
Indeed. Yeah. And I think it's a good thing. Okay, so these are all the good things that happened. Well, are there? This is a bit of a curveball question. Any bad decisions? What do you think didn't work out so well? Feel free to pass on this one if you don't want to go into it.
I mean, I can't think of anything in particular. I think I'll bring up a couple. Like I don't know of anything in particular where the team's like, we shouldn't have done that, or at least not that I know of in conversations I was in. I know that there is a general thing that I've always said about APIs, which is that building APIs is building future regret, because you build the best thing that you can at the time, given the requirements that you're aware of. But in the future, people are going to use this API in different ways. And now you're basically painted into a corner because you can't change the API because you will break existing apps or new apps if you start changing the APIs. And so you have what you have, and you can introduce new APIs, but then you have to migrate people over to them. You can introduce sort of parallel APIs to expand on it, but sometimes it just ends up looking a little bit clunky. I've certainly had this with some of my APIs, you know, some of the animation APIs that I wrote on Android, where 3 years later it was like, oh, if only I had done it in this other way, it would be a little bit more flexible. So that's one area. I think that's a general software thing, or at least for platforms that have APIs. APIs is kind of a special case of software, because if you're just shipping an app, you can rewrite the entire app as long as it has the features that you want. But if you're shipping an API, that's it, right? You don't want to break people. And so you really are kind of stuck after you've made those decisions. I think another area that people have brought up is the complexity of the life cycle. And it's related to Binder, but it's a really complicated thing to understand, either for activities or for fragments. And I think there is a question that I cannot answer about whether it needs to be that complex, and whether there's sort of this level of complexity built into it that made sense to the authors of that other, did it need to be that complicated? Other people have a hard time understanding it. And then the problem is with any complex system, if you don't completely understand it, you may end up doing things in the wrong way, right? And then, your app is exiting at the wrong time, or it's, not handling multi-threaded capabilities in the correct way, and there's a crash or whatever. But it was really, if you look at some of the earlier diagrams of this is the Android lifecycle, it was like super complicated flow chart. And that wasn't even really all the pieces. And so there is, I think, that level of complexity. I don't think that is a team regret, but I do think that it's a debate about, was there a different way to do that? Because it's an inherently complicated thing, right? You have multi-threaded operating system, multi-threaded and multitasking in the apps themselves. You have all these signals coming in trying to do all these things at the same time. And then you need to do the right thing with the life cycle. Like it's a complicated problem to solve. So you're going to end up with a complicated solution. And then it's an academic debate about whether that is the right solution or not.
I guess this has become so ingrained in application writers these days that pretty much any resistance there may have been to start with, I think it's pretty much been overcome. People have kind of seem to be happy with that. And yeah, I don't know. I'm not an application writer, I should say, so I don't really know the details of this.
I hope so. Yeah. I think if you're dealing with it now, there's two things that help. One is it's been the same for a long time, and hopefully you are hip to what you need to do. I think the other part is that the team has been good in the last few years between Android X as well as core platform APIs about adding capabilities to make it easier to do the right thing. So, utilities on the outside where you can, it makes it a little bit easier to deal with some of these things that you needed to do than the raw APIs that were released at first. I see there's some questions in the chat. I don't know if you wanted to get to those.
Yeah, I was just going to read out. So Amol says, did Android have any GPL components in the early stages? Why Linux kernel if AOSP is GPL averse in general?
I am absolutely the wrong person to talk about software licenses. Linux kernel made sense, and this is not from a license perspective. Linux kernel made sense because it was there. It was available with whatever license the team needed. There was a lot of driver support. Like, it was the known thing at that low level of the platform. And as far as GPL, I don't know. I am not a lawyer. I'm not going to be a lawyer. I'm not going to answer that question because I don't know. I'd be wrong.
Yeah. Yeah, I would just briefly put my opinions in here because I have quite strong opinions on this. It'd be really great if Android had more GPL components. I feel the no GPL rule has really hurt Android in that it ended up with a fairly poor quality C library. It didn't make use of certain components like BusyBox would have been useful in the early days. Now we have Toybox, but that wasn't there then. There's a whole bunch of GPL stuff that would really have helped. So I do feel that kind of, my own personal view is that has been a hindrance, and I don't see that it's has helped the business case of Android in any way. But and yeah, that's just my opinion. The other thing, we're almost out of time, but just one other thing I just want to kind of bring up. So I was saying, some things that are problematic, probably the wrong word, but are issues with Android, is really the kind of tension between Google and the OEMs. So on the one hand, Google are producing AOSP, and that is then taken by the OEMs, who then customize it and build it into their products of whatever sort. And it seems that there is always a kind of tension between who has control of this. And over the more recent past, Google have tried to take more control of that with things like Project Treble and Project Mainline, so that they have more control over some of the components. And now we have the GKI. Yeah, so it seems that as we've gone through, Google are kind of clawing back some of the control over the Android code base and taking it back in-house. Is that how you see it? Obviously not.
Yeah, no, it's not really a part of the stuff that I deal with. I know that like having the AOSP stuff out there was and is still really important. The aspects to which that's being undermined by some decision, I have no idea.
Okay.
Yeah, I don't know. I mean, I think we do like that everybody can take this and ship their stuff, and everybody can also contribute fixes back to sort of make it better in general. But that's at a theoretical level, and I'm not aware of any of the specifics there.
Yeah, I can say from an outside of Google point of view, trying to get your fixes into Android is very difficult.
Yes, it is.
The Android dev team are not particularly interested in taking code from the community, if you like. And indeed, there isn't that much of a community at the system level.
Yeah, I mean,
this is why I set up this group.
I am, and I'm glad you did. Like, I'm glad that this exists, because although AOSP is really important to Google, I think there's not besides it existing, there's not a huge business reason to make it a rich community from the inside, right? Like, it's really important for Google to focus on the platform itself. And the community of people that want to take AOSP directly is quite small and focused on manufacturers that have the wherewithal to learn what they need to and take it. And beyond that, like, you got to justify the time spent on that thing. And I think that's tricky for any company, to dedicate resources to something that they're not seeing direct benefit from. Having said that, I lost my train of thought. It's about, well, can we go back to the earlier point? Remind me what you were saying.
Which one? So, so I think I started this thread off by saying there's this tension between Google and the OEMs and who controls which part of the operating system.
Yeah, that was the part that I don't have any knowledge
expanding that
on.
beyond OEMs, also other developers. So I noticed Mateus from Bay Libra, who does a whole bunch of work on porting AOSP to various devices, including the VM3, which I mentioned in the thing. He comments that it is difficult to get stuff into AOSP. So there have been, for example, well-known bugs in Bluetooth that have been kicking around for a long time. Everybody knows what the solution is, but trying to land that code into the AOSP developers is hard. Yeah,
sorry, that was the area I wanted to address. So I'm sure you're right. I have not tried to contribute code from the outside. I think there is a theory that we always wanted to take contributions. There is a trickiness to it because we do. So I always refer to it as eventual open source, which means we're working on a release for a year, and then our code gets out there, which means if you're trying to fix code, you're automatically getting a snapshot of the code that is older than the stuff that we're working on. And so it's not easy for you from the outside, for anybody from the outside, to know where the code is at or how well that's going to integrate. If it's just, old code that's stable for many years, that's different. But if it's any ongoing stuff, well, it may be changing out from under you. And then it's tricky for you to figure out what to do. It's also tricky for the people inside to say, well, that's interesting, but then how do we map this to where the code is now? And then just the overall complexity of anybody contributing to something this big when it's hard to understand more than, this little slice of it. Like, how does that fix integrate with everything else going on? And the more complicated, the more interesting the fix is, the more complicated it probably is, or the more it may tie into complicated interactions and integrations with other code. And then it just becomes a headache for these people, to figure out what do we do with this? There is the hope that we can use these fixes. And I know it's been an effort occasionally to say, okay, well, somebody submitted this fix. Can we find a way to integrate that? Even if it's not the exact fix we need, can we take it and then, merge it in the correct way? But I think the more complicated it is, the trickier it is to do that. And I think there's an advantage. Someone made a comment about being a partner. I think there's an advantage to being a partner just because those are necessarily the people that are going to have more familiarity overall, because they're probably, that organization is working on this chunk of code for a long time, and so they're going to have more context. So I don't think it's necessarily like a business thing, like, oh, we need to take, this partner's code, but more that there's a reason why that code is going to be easier to integrate, because they're doing ongoing changes there. This is my theory of some of the complexities and how they're solved. Your experience may be different than my theories.